Hey everyone, this is Big Ideas 1.3 where we're looking at modeling with linear functions. So we're going back and looking at linear functions a little bit again, but this time we're going to be looking at maybe some more real life situations, more of a data situation given not just the equations of lines that we looked at before, but now kind of writing equations from maybe groups of data and information. So that's what we're kind of looking at. How can you use a linear function to model and analyze a real-life situation? So we're looking to focus a little bit more on real-life situations. All right, well, for our cartoon, we have an In the Bleachers cartoon. It says, I'm going to bend your knee. If it hurts, I want you to scrunch up your face in agony and let out a blood-curdling scream. The guy playing soccer had a knee injury. Of course, he's going to do that if he bends his knee. Alright, so if we look at the linear functions, we just need to be reminded of what we've already learned for linear functions. This is what this core concept is reminding us of. The different ways we can write a function. We can write a function or an equation of a line, a linear function specifically, with using slope-intercept form. So again, this is for linear functions. Y equals mx plus b. And then we also have the point-slope form, which is y minus y1 equals m times x minus x1. Where the x1 and y1 are from an ordered pair that it gives you. So it might give you the slope number and it gives you an ordered pair. You can plug it into this. And then if you have 2 points, you can find the slope by just subtracting the y's over subtracting the x's that I wrote down here. You want to write that down also underneath this. So we need to first find the slope using this little formula. And then we can choose one of these 2 points to be our x1, y1 points. And it wouldn't matter which point you chose. So again, we're looking at linear equations, straight lines, and we're trying to write, some kind of a real-life situation into this kind of form, depending on what it asks for us to do. But so let's go ahead and right underneath this core concept, we're going to do just a little bit of review real quick to write some more of these. Okay, so right there on page 15, underneath that notes section, go ahead and just write number 1, write an equation. M equals 4, so our slope is 4, and it gives you an ordered pair of 2, 3. And so we're going to write it in, I'm going to show you how to write it both ways. We can just plug it straight into the y equals mx plus b, so that's one way we could do it. Or there's also another way we can use this point-slope form also to do it as well, where the x1 and the y1 would be these numbers here, the 2 and the 3. So if we start with looking at this form, what we can do is plug in everything we know. We know m, we know x, we know y from this equation. We just don't know b. So we can plug everything we know in. So 3 is y, 4 is the m, 2 is the x. Multiply 4 times 2 gives us 8 there. And then just subtract 8 from both sides to give us a negative 5. So we know now b is negative 5. So now that we know the m and the b, we then can just write our equation of y equals 4x minus 5. So there's our m is 4, b is negative 5. We could have also got the same equation, plugging it into this point-slope form that we've done before. So we put in, we put in the m here, the 4 goes here. Here's our numbers, so 3 is here, 2 is over here. So we plug everything in. And then we just can, in this case, if we needed to leave the equation in point-slope form, we could actually just leave it right there if it asks for point-slope form. But if it wants it in this form here of y equals mx plus b, which is slope-intercept form, then you need to distribute this, kind of convert it here by distributing 4. Gives you 4x minus 8 here, 4 times 2, there, the 8. And then you want to, get the 3 over on this side, so you're going to add 3 to both sides to get the y by itself. And so now you have y by itself, you have your 4x, negative 8 plus 3 there is the negative 5. And so there's the same equation. So that's how you can write an equation in slope-intercept form, either just going straight into that form, finding the b first, or you could use the point-slope form and then convert it to slope-intercept form. There's right number 2 down. It says find the slope of the line containing these 2 points, then write an equation. And we'll put the equation again in slope-intercept form because that's usually the most common form they want it in. So to write or find the slope of the point between these 2 points here, or I should say the line between these 2 points, we would want to use our little formula here where we can just subtract the y's over subtracting the x's. Now it doesn't matter which one you start with. I usually just start with the first one, doing the first point minus the second point. you could do the second point minus the first point. You just need to be consistent and start with the same one for y and for x. So we can see this as our x and our y's, remember, are here. So we start with y's as the second number, so I'm going to start with this one first. So negative 2 minus 6 I'm going to put on top. And then below that I'm going to start with 3, since I started with this point. We're going to start with 3 minus negative 1, which is a double negative, changing that to a positive. 3 minus a negative 1 will become 3 plus 1. And so now we just simplify this. We're going to get negative 8 over 4, and that would reduce down to negative 2. So there is the slope of the line containing these 2 points. And now we need to write an equation. We can use the slope and one of these 2 points. It doesn't matter which one we use. I'll just use this first one here. So we're going to plug it into the y equals mx plus b just like we did with this one here. So I'm going to plug everything I know except the b I don't know. So y from this point is negative 2. And then the slope is negative 2, our m. The x from the point we're using is 3. And now this will become a negative 6 right there. And then we're going to have to add 6 to both sides to solve for b. And so we add 6, we're going to get 4 on the other side, so b is equal to 4. And now, since we know the slope is negative 2, the b is 4, we can write our equation of y equals negative 2x plus 4. So there it is. There's a slope of negative 2. Positive 4 is the b. That's the y-intercept number. Okay, so that was just a quick little review. We're going to use this same information to help us do some real-life ones now. Okay, so here on page 16, the extra practice at the bottom, for these first 3, it says use the graph to write an equation of the line and interpret the slope. So when it says write an equation of the line, we're going to do exactly what we just did on that little review. But then we also want to interpret the slope because we now have a real-life situation, so we can interpret what the slope means. So for number 1, we have a cell phone cost here on this graph. The y-axis is about the cost, and the x-axis is about the number of text messages sent. Now this little jagged part just means that you have more space in between here than just 10. So even though like we're going on the x-axis here, everything is worth 5, so you have 5, 10, 15, 20. This one you have, this is not 24 and then 48, so it's not going by 24s as you can see. What's it really going by from 48 to 50? Well, it looks like it's going 48, 49, 50, 51, 52. So really this would be 47 right here. So between 0 and 47 is why that jagged spot is right there. So if you ever see that, you just know that just means there's a whole lot of space there we don't really need. It's like a bunch of dead space in the graph that we don't need to have on our graph, because our graph's going to be way up here on the top. So here's what we do. We have 2 points, 0,50 and 10,51. We want to first find the slope between those 2 points and then write the equation from that slope, trying to find the y-intercept. So starting with just subtracting the y's on top like we just did. So we can do the top one minus the bottom one if we want to do it that way. Since these are bigger, it might be easier to do it this way, 51 minus 50. So then we would do 10 minus 0 below that to get the right thing. If we did it the other way, if we did 0 minus 10, our sign would be wrong, and so we don't want that to happen. So we have 1 over 10, it looks like. A 1/10 is the slope number. And so now we're going to use our y equals mx plus b and plug in what that would be. Actually, we don't need to actually plug everything in because we know what the b is. You can see there's your y-intercept. The b is the y-intercept. It is the 50. So whenever x is 0, that is your b. Right there, 0, comma b. So b is 50 on this one. We didn't have to plug it in. We will on some of these maybe. On this one we definitely will. On number 3. So if I know my slope is 1/10, the b is 50, I could just plug that in. Y equals 1/10 x plus 50. There it is. There's our equation of this line. And then if we want to interpret this, what does this really mean of 1/10? Well, maybe think of it in terms of money. 1/10 would be like 10 cents of a dollar, right? So it's like 0.10 or 10 cents. So we're actually talking about text messages, right? And how much a text message, one text message would cost. So we can think about that. So it's 10 cents per text. So originally you have like, $50 it's going to cost you just to be able to do text messaging, it looks like, right here. And then from that point on, it's 10 cents per every text after that. Number 2, we have a travel distance here. The distance is the y-axis, the time is the x-axis in hours. And so again, we have a y-intercept there. We need to know what the slope is by subtracting the y's. We can start with the bigger number, 360 minus the 0 on top, and which means we're going to be doing 0 minus 6 below that. And so it's going to give us 360 over negative 6, and so that's going to end up being a negative 60 for the slope. It is going downhill, as you can see. From left to right, it's going down, and so that is a negative direction, a negative slope that way. And we know what our b is. Our b is 360 right there, because it's always 0 comma b. So we can just write it in our equation. B is 360, so it's going to be y equals negative 60 for the slope, the m, x plus the b. So negative 60x plus 360 is our equation. That's our slope-intercept equation. Now, as far as interpreting what this means, looks like we're going down here. So here's what we're talking about. It's going to be, 60 for every, it looks like for every distance here, for every hour, for x, as you plug in an hour, it looks like you're traveling, so 60 miles per hour is what you're doing. So you're traveling, because you're going from your destination here, travel distance, it's going to be like a trip. The trip is 360 miles away, and for every hour you're traveling 60 miles off of your total distance, getting down to eventually your destination right here is your destination. So 60 miles per hour is what our slope is talking about. And then for the math homework grade on this one, our homework grade is the y-axis, completed assignments is the x-axis. And so we're going to again do the same thing as about subtracting the y's. I'm going to go ahead and do the top one minus the bottom one here, because they are bigger numbers on top. So 95 minus 85, and so it's going to be over 20 minus the 10, and so it's going to end up giving us 10 over 10, which equals 1. So our slope is 1. This one we can't really decide where or determine what our 0 comma b is here, what the y-intercept is, just by looking at it. So we want to actually figure this out using a point. So we'll pick one of these 2 points, it doesn't matter which one, and plug it into the y equals mx plus b, solve it for b. So I'm going to pick the 1085 points. 85 is the y, 1 is the m, 10 is the x, and then we'll find out what b is from there. And so we're going to subtract 10 from both sides, because 1 times 10 is 10, so subtract the 10, 85 minus 10 is 75. And so then we have b is 75. And so then at that point, we could see our equation would be y equals 1x, or just x plus 75. And so then we want to think about, okay, what's the slope mean on this one? So one assignment equals, so much percent of the grade. Your homework as far as a percent goes here, one assignment would be equal to 100% of that assignment. So that's all that's talking about, the 100% per assignment in this one. Okay, so number 4, this problem here is a comparison problem. And this one's they oftentimes want to give you this problem in tests and things, so you're going to be paying attention to this one in particular. It says the cost of parking in a parking garage in Chicago is represented by the equation y equals 15x plus 20. So again, that's a linear equation. Your slope is 15, your y-intercept is 20. That's what we need to be able to recognize from this equation right here. Slope 15, y-intercept 20. Y is the total cost in dollars, x is the time in hours. Now the table, so here's another function here, the table shows the total cost to park in a parking garage in Denver. So these are 2 different ways to represent a function, a linear function. So this is a equation, and here is a table of values. So x is just a bunch of ordered pairs. So both of these are linear functions. They're saying which city's parking garage charges more per hour and by how much more? After how many hours would parking in both cities cost the same? So we're going to first deal with this first question, which city's parking garage charges more per hour and by how much more? So we can already identify from the equation how much Chicago, which is this equation here, charges per hour. So if you plug in 1 So what we basically have 20 right here. This would be like an initial cost, but then 15 is the hourly rate. So 1 hour, you're going to say 1 times 15. And so that would be, so actually if you're going to spend 1 hour there, you're going to pay the 20 no matter what. But then 1 times 15 is $35 for that first one. If you go 2 hours, it's going to be $15 more. You'll be up to $50 because that'll be 30 plus 20. So you're going up every hour. It's $15 more. So that's what the slope is referring to. Your slope is the amount per hour. So this would be $15 per hour Chicago. For this one, you just need to find the slope of this table. There's a couple different ways that we could find this slope. One we could do is just identifying what the change in y over the change in x is. Remember, y is going to always be on top, x is on the bottom. Like when we subtract the y's on the top, subtract the x's on the bottom. But what's the change in y as we go from 43 to 51, 51 to 59? As you can see, you're going up by 8. Positive 8 is the change there. And what's going on with the change in x? 2 to 3, 3 to 4, 4 to 5. The change there is just going up by 1. So we can say the change in y is 8, the change in x is 1. So it's 8 over 1, which would be simplified to 8. So $8 an hour is the Denver one right here. So it says, which parking garage charges more per hour? So we can already answer that question right here, and by how much more? So obviously Chicago charges more. 15 minus 8 is $7 more. So Chicago charges $7 more per hour. That's what we want to do to answer that first question. We could also have found the slope. If you didn't do it this way, you could have also done it this way with the way we've done it before. Take 2 points right here. You can just take the first two. The first two y's, 51 minus 43 right there, over 3 minus 2. Just again, be consistent. Start with the same point and end with that same point. End with the other point. And that still gives you 8. So you can do the slope either way. Now to answer that second question, after how many hours would parking in both cities cost the same? So what we need to do is we need to convert this Denver function here into an equation like this one is right here. So we do need to, again, finish off y equals mx plus b. We know what a slope is 8, but what is the b number here? So we're going to pick one of these points up here to be our x and our y numbers. And I'm just going to pick that first one. So 43 for y, 2 for x. Plug it in, you're going to get 16 right here. We're going to subtract 16 then from both sides. 43 minus 16 then would give us 27. So the b is 27, so we can write the equation for Denver as y equals 8x plus 27. 8 being the slope, 27 is the y-intercept. And so now what we want to do with this equation is we want to set these two equal to each other. So when are they going to cost the same? So the cost is the y. When are they going to be equal to each other? So all you need to do is just substitute this one in for the y up here or down for here, it doesn't matter, but basically make them both equal each other. So 15x plus 20, when is that going to equal 8x plus 27? And we'll find out by solving for x. How many hours is it going to take for the cost to be exactly the same, to be the same number? So that's why we're setting them equal to each other. So we start by getting the x's together. I'm going to subtract 8x from both sides. 15 minus 8 is 7, so 7x plus 20. And now we subtract 20 from both sides. 27 minus 20 is 7. And then divide by 7. 7 divided by 7 is 1. So x equals 1. After 1 hour, it's just going to take 1 hour for the cost to be the same. After 1 hour, they cost the same. So if we say, okay, 1 hour for this one here would be 8 plus 27, that's 35, and we already said 1 hour for this one was going to be 15 plus 20, that's 35 as well. All right, moving on to the rest of our lesson. Let's do a little quick joke of the day. Why couldn't the bicycle stand up? Why couldn't the bicycle stand up? Because it was too tired. Okay, so on page 16, you're going to see this core concept, finding lines of fit. Basically, what a line of fit is, and you have that vocabulary word, you could write this down. It shows an approximate linear relationship is what a line of fit would do. So it basically take some data. So if you model data and it has a linear relationship, then you can have a line of fit. And so to find a line of fit, you have some kind of, you have to create a scatter plot from the data. That basically means you're going to just plot all the points from the data that you get, all the x and y points, sketch the line that most closely appears to follow the trend given by the data points, and there should be about as many points above the line as below it. And then choose 2 points on the line and estimate the coordinates of each point. These 2 points do not have to be original data points even. And then from those 2 points, you're going to write an equation of a line that passes through the 2 points from step 3. And this equation is a model for the data. And you can have more than one equation. There could be different equations, but they all should be fairly close. So here's an example of doing one. Here's some data. So x and y. So you have a femur length, that's a bone in your leg, and then height of a person. So the table shows the femur lengths and heights of several people. Do the data show a linear relationship? If so, write an equation of a line of fit and use it to estimate the height of a person whose femur is 35 centimeters long. So I'm just going to kind of show you this. You don't have to write anything down from this, but you can just get the idea of what we do. We would just plot all these points on a coordinate plane, and you don't have to make it a full coordinate plane. You can just do, since these are all positive, just a little L graph. Remember, there's that squiggly right there. They used that there because they are going by fives, but they didn't really need all this dead space over here at the beginning because their first point isn't until around 30. And so they plotted all the points, and they all somehow had a linear relationship, as you can see. They're not scattered all over the place. They kind of will line up in some way. They're all kind of in the shape of a line. And so that would show that it definitely does have a linear relationship. And so then you would want to try to draw this line. That's step number 2, is you're going to sketch the line that closely appears to model this data. And then pick a couple points that would be on that line. As you can see, they picked a couple points there. And so those 2 points, from those 2 points, they're just going to write their equation of a line. First they find the slope, and then they use that. They use the point slope one on this one. They plugged it in, and they eventually converted it back down to the y-intercept one, or slope-intercept, I should say, y equals mx plus b equation. And so that's what they're doing on that. The last question does say, let's see, what did it say? Estimate the height of a person whose femur is 35 centimeters long. So you could plug in 35 then for x right here and do that little estimation. That's all they're going to do there. Plug that into your line of fit, and you can estimate there it would be 157.5 centimeters is the approximate height of the person. All right. Now you also have this vocabulary word also on your vocabulary in the notes. Line of best fit. It's pretty much the same thing almost. The line that lies as close as possible to all of the data points. That's kind of like what we were just doing. So that's what you can do. Many technology tools have a linear regression feature that can do that. We're just going to, at this point, just look at a line of best fit, kind of like what we were just doing for a line of fit. Using this linear regression feature on a graphing calculator like a Desmos calculator, that's something we can do in class. Okay, so on page 17, for these last 3 graphs, it does talk about using a linear regression feature. We're not going to do that on these ones. We're just going to look, first of all, does it show a linear relationship? And the word they use here is correlation for relationship. So you can see even the word relation is kind of in that. So instead of saying relationship, we're going to say linear correlation. So number 5, you can see this one is kind of all scattered about. There really is no linear correlation to this one. So we would just say for this one, there is no linear correlation. We want to, if it does have a linear correlation, we do want to find an equation of the line of best fit. So we're going to try to do that as well. But for number 5, there is no linear correlation on that. They're just scattered about. 6, however, you can see they are kind of lined up. They're not perfectly lined up, but they're pretty close. So this one definitely has linear correlation. And so we want to draw a line that would be best fitting this. So you can kind of draw as best you can a line here where it's kind of right through the middle of it as best as possible. And so I'm starting from there. I'm kind of going through. I got this one a little bit below it here, but some of these other ones are pretty close to even on the line, and it kind of does hit down below here. So I could see definitely some 2 points then, a y-intercept and an x-intercept points. I can use those points, 5, 0 down below, and then 0, 25 up there. And then now let's write an equation using these 2 points. So first find the slope of that, so subtract the y numbers, 25 minus 0 on top. Subtract the x numbers on the bottom, 0 minus 5. So if I'm starting with this point on the y's, I got to also start with it on the x's. So I'm starting with the top point. And then 25 over negative 5 is going to give us a negative 5 for slope. So it is, you can see it's a negative correlation, negative linear correlation, because it is going down. And so then we can identify 25 in this case would be the b. So b would be 25, and then write the equation y equals negative 5x plus 25. There's our linear equation of that line of fit of that data. Number 7, does this have a linear correlation? Well, it looks like it does as well, because it's kind of lined up a bit, not perfectly, but close enough to have a linear correlation. So yes, that has linear correlation. And so to try to do a best job of going through this, where you might have some points above it, some points below it, you can put that in there like that. You got most of the points on the line. This one's a little bit below. That looks like it's on. It's a little bit above the line. This one's a little further above the line. So I just drew it through here. So this one's kind of a little bit too high, but that's okay. We're going to use these 2 points then as our points to go off of to write the equation 0, 1 and 8, 5. And that point we can then subtract the y's on top. I'm going to start with the top point up here, 5 minus 1. And then that means 8 minus 0 would be on below that. So it's going to be 4 over 8, which should be a 1/2. And so our slope is 1/2. And we can see again, this would be our y-intercept. It would be 1, so b is 1. So our equation would just be y equals 1/2 x plus 1. All right, so this concludes our 1.3 lesson, and you want to go on to the assignment for this lesson, and I'll see you on the next video.